Much of the discussion about climate change has concentrated on temperature. What we look at on this graph is precipitation, which is equally important. The dark line shows the estimate of the observed global precipitation over land from the Climatic Research Unit of the University of East Anglia. Estimating precipitation on a global scale is much more difficult than estimating temperature. When you think about it, the reason is obvious. If you have two climate observing stations a few kilometers apart, it is unlikely that there will be very much difference in the temperatures. On the other hand, there could be a very significant difference in the precipitation. So these values are probably less accurate than the equivalent ones for temperature. The red line shows the simulated precipitation from a group of 7 models for precipitation over land. This is the equivalent of the observed line from the Climatic Research Unit. The third line shows the simulated precipitation over sea and land from the same group of 7 models. As you can see, there are very big differences between the observed values and the simulated values. Some of this may be due to errors in the measurement, but it's unlikely to account for all of it. Another feature is that the observed record varies quite a lot. First of all, at a long time scale, and secondly, at a short-term time scale. On the other hand, the simulated record hardly varies at all, neither on a short-term nor on a long-term time scale. The fact that the lack of variation is so evident may in part be due to the fact that we're using the average of a group of models, though remember there are no such problems with the temperature, but it's unlikely to account for all the lack of variation in the simulation.